There is a darkness between stars that human eyes were never meant to pierce. Cold, absolute, a void so empty that light itself seems to hesitate before crossing it. But on July 1st, 2025, something bled through that darkness. Something that caught the light and held it, shimmering like liquid mercury against the infinite black. It moved fast, impossibly fast. 130,000 miles per hour through the outer reaches of our solar system, carving a path no natural object should follow. At first, astronomers celebrated. Another interstellar visitor, they said. The third ever detected after Oumuamua's mysterious tumble through our cosmic neighborhood and Borisov's icy flyby. They gave it a designation, 3I/ATLAS. They prepared their instruments, they aimed their telescopes, and then the sensors began returning data that made no sense. Not dust, not ice, not the crystalline signature of water vapor sublimating in sunlight. Instead, telescopes detected a plume of something that shouldn't exist in nature. Refined nickel, pure, separated, gleaming. Everywhere in the universe, nickel and iron are forged together in the nuclear furnaces of dying stars. They're cosmic twins, inseparable siblings born in the same stellar catastrophes. Supernovae don't discriminate. They bind these elements together in meteorites, in asteroids, in the molten cores of planets. Finding pure nickel without iron isn't just rare, it's chemically impossible through natural processes. Unless something refined it. Across the world, experts stared at their screens in silence. Video calls flickered with faces lit by monitor glow, spectral graphs bleeding red across their pupils. At the Very Large Telescope in Chile's Atacama Desert, astronomers recalibrated their instruments 3 times. At the Space Telescope Science Institute in Maryland, the Webb team cross-referenced their readings with every known cosmic phenomenon. The data didn't change. Pure nickel, concentrations that would require smelting temperatures above 1,450 degrees Celsius. Deliberate separation that nature, for all its violence and grandeur, had never accomplished in bulk anywhere in the observable universe. The word no one wanted to say hung in the air like static before a lightning strike. Artificial. If this object could refine its own metal, it implied something far more unsettling than a rogue asteroid from another star system. It implied engineering, design, purpose. It meant something out there possessed technology sophisticated enough to process materials in the depths of space, and that technology had just crossed the threshold into humanity's home system. But the nickel was only the beginning. Buried in the electromagnetic noise surrounding the object, hidden in frequencies most instruments routinely filtered out as interference, analysts began detecting patterns. Not random, not natural. Radio-like pulses embedded in the metallic gas emissions, repeating at intervals too precise to be coincidence. One astronomer, reviewing the data at 3 a.m. in a cramped office at MIT, felt his hands begin to shake. He stared at the waveform on his screen, peaks and troughs rising and falling like a heartbeat, like a message, like a question. If it isn't a rock, then what exactly did we just invite into our solar system? The Atacama Desert has always been a place of secrets. High in the Chilean Andes, where the air thins and the sky opens like a wound, the world's most powerful telescopes stand sentinel against the darkness. On July 1st, 2025, at 23:47 UTC, a 28-year-old astronomer named Sofia Ramirez sat alone in the control room of the Blanco telescope, watching automated survey data scroll across 3 monitors. The only sounds were the hum of cooling fans and the whisper of desert wind against reinforced glass. She almost missed it. A bright point moving unusually fast across the field of view, trajectory all wrong for an asteroid or known comet. She flagged it, ran the preliminary orbit calculation, and felt her breath catch. The object was moving at hyperbolic velocity, faster than the sun's gravity could account for. It came from outside. Within hours, observatories on 3 continents confirmed it. Headlines erupted across astronomical forums and press releases. Third interstellar visitor detected. Academic Twitter exploded with excitement. This was history. Another messenger from the cosmic deep, carrying with it chemical fingerprints from stellar systems humans would never reach. For 48 glorious hours, the discovery felt like pure science, like wonder. Then, the Very Large Telescope completed its spectroscopic analysis. Ramirez stood in the VLT control room 2 days later, surrounded by senior researchers, watching the spectral data resolve on the main display. She expected to see the familiar signatures: water vapor, carbon monoxide, dust particles, the organic chemistry of a comet born in another star's nursery. Instead, she watched the graph paint a flat line where ice should spike. Where water should bloom in the infrared, there was nothing. But in the ultraviolet range, where metal signatures hide, the display lit up like a Christmas tree. Nickel, pure nickel, not trace amounts, not impurities mixed with stone and iron. A halo of metallic gas surrounded the object, glowing in wavelengths that suggested active sublimation, materials vaporizing off the surface as it warmed. Dr. Chen, the lead researcher, removed his glasses and cleaned them slowly, deliberately. His hands weren't quite steady. "Run it again," he said quietly. They ran it again. The results didn't change. Refining nickel from iron-nickel alloys requires precise metallurgical processes. You need heat, yes, furnace temperatures exceeding 1,450 degrees Celsius, but you also need separation. You need electrochemical reduction or vapor deposition, or any number of industrial techniques that took humanity millennia to develop. Nature doesn't build smelting factories. Stars forge elements, but they don't purify them. Finding this in space was like finding a polished steel ingot drifting through the ocean. Not a boulder, not a chunk of ship, an ingot shaped, processed, deliberately made. Dr. Marcus Okoye, a Harvard astrophysicist invited to review the data, stared at the readouts for 15 minutes without speaking. Finally, he looked up at the assembled team and said the words that would define the weeks to come. "This isn't a rock. It's engineered." The room went silent. Outside, the Atacama wind howled against the observatory dome, carrying away the sound of everything they thought they understood about the universe. When NASA redirected the James Webb Space Telescope toward 3I/ATLAS, they did so quietly. No press release, no public announcement. The gold-plated hexagonal mirrors, suspended a million miles from Earth at the L2 Lagrange point, turned their gaze toward something that shouldn't exist. Webb was humanity's most sophisticated eye on the cosmos. Its infrared instruments could analyze the atmospheric composition of planets orbiting distant stars. It could peer through dust clouds to watch stars being born. If anything could reveal the truth about this object, it was Webb. The data took 3 days to process. When the results arrived, they were worse than anyone anticipated. Webb's near-infrared spectrograph revealed something that violated every model of cometary chemistry, an 8-to-1 ratio of carbon dioxide to water vapor. Most comets, born in the frozen outer reaches of stellar systems, carry abundant water ice. Carbon dioxide exists, yes, but typically represents only 4% of their composition. This was the inverse. This object carried 20 times more CO2 than it should. Dr. Sarah Chen, leading the analysis team at the Space Telescope Science Institute, pulled up comparison data from every comet humanity had ever studied. Nothing came close. Not Halley, not Hale-Bopp, not the pristine samples returned from Wild 2. "This ratio," she said slowly, addressing the assembled team via secure video conference, "would require formation in conditions we've never observed. Extreme cold, minimal water, an environment that prioritizes carbon compounds over hydrogen bonds. Or, left unsaid but hanging in the digital silence, an environment that was manufactured. Carbon dioxide is stable. It doesn't react easily. It's an excellent medium for preservation, for containment, for transporting other materials across the void. Earth's own engineers use CO2 in cryogenic storage, in fire suppression, in environments where you need chemical inertness. What if this wasn't a body? What if it was a container?" The thought spread through the scientific community like frost across glass. A vessel, a capsule, something built not through gravitational accretion and stellar chemistry, but through deliberate engineering, loaded with specific compounds, sealed against the vacuum, sent across light years with purpose humanity couldn't yet fathom. The debates began immediately. Institutions split along theoretical lines. Some argued for exotic chemistry, for carbon-rich protostellar disks that might naturally produce such ratios. Others, in careful language designed to avoid ridicule, suggested what the data increasingly demanded. This object might be artificial. Press conferences became exercises in careful omission. Public statements spoke of unusual chemistry and further investigation. Behind closed doors, in encrypted calls and classified briefings, the conversations grew darker. If its composition implied design, What was that design meant to accomplish? What intent could pure metal and carbon dioxide, drifting through the cosmic dark, possibly serve? And more unsettling still, who sent it, and what were they looking for? Orbital mechanics is mathematics written in gravity. Bodies move according to laws that Newton described and Einstein refined. Trajectories are predictable, calculable, reducible to equations that yield one correct answer. When 3I/ATLAS entered the inner solar system, its path should have been simple, a hyperbolic arc, sweeping past the sun and fleeing back into interstellar space. Instead, it did something impossible. It skimmed Venus at a distance of 0.3 astronomical units, absorbing a gravitational slingshot that bent its trajectory inward. It brushed past Mars, threading between the red planet and the asteroid belt with mathematical precision. Then it whipped around Jupiter's massive gravity well, emerging on a course that would take it past Earth's orbit twice, once on approach, once on departure. Analysts at JPL ran the probability calculations. The odds of a random object naturally following such a path? 0.005%, 1 in 20,000. Less likely than being struck by lightning while holding a winning lottery ticket. But statistics alone didn't capture the full strangeness. The real anomaly was the object's motion relative to the solar system's fundamental architecture. Everything in our cosmic neighborhood, planets, asteroids, comets, orbits the sun in the same direction, counterclockwise, viewed from above Earth's North Pole. This rotation is baked into the solar system's formation, an echo of the spinning disk of gas and dust that collapsed 4.5 billion years ago. Even objects from the Kuiper Belt, even rogue asteroids follow this ingrained choreography. 3I/ATLAS moved backward, retrograde motion, against the flow. Like a car driving the wrong way on a highway, fighting traffic, defying the fundamental momentum of our star's domain. In mission control rooms from Houston to Darmstadt, trajectory specialists watched monitors plot the object's course as a glowing thread wrapping around the inner planets. The path looked almost deliberate, as if it were observing them, measuring them. Venus, Mars, Jupiter, Earth. The 4 worlds with either atmospheres or moons. The 4 locations in the solar system where complexity thrived. And then there was the perihelion problem. At its closest approach to the sun, 3I/ATLAS passed directly behind our star from Earth's perspective. For 6 days, every telescope and sensor went blind. Solar radiation drowned all observations. When the object emerged on the other side, tracking stations had to relocate it based on predicted trajectories. It had chosen, if an object could choose, the one corridor through the inner system where human observation went dark. Some called it coincidence, others called it strategy. One analyst, exhausted after 18-hour shifts running simulations, looked at the plotted course and said what others were thinking. It moves like it's guided. The room went quiet. Maybe, someone replied softly, it is. The first hint came from an atmospheric chemist at Caltech who wasn't even looking for patterns. Dr. Amara Okonkwo had been analyzing the metallic gas emissions, trying to understand the ratios of different elements in the plume. Nickel dominated, yes, but trace amounts of carbon, silicon, and sulfur appeared in the spectroscopic data. She was running statistical analyses on the ratios when her software flagged an anomaly. The proportions weren't random, they repeated. Nickel to carbon held steady at 7:1. Silicon appeared in bursts corresponding to prime numbers. 2, 3, 5, 7, 11-minute intervals. Mathematical sequences. In chemistry, she called it a calibration error. Then she checked the raw data and found the same patterns staring back at her, undeniable and precise. Within days, SETI researchers were examining the emissions through frameworks developed for detecting artificial signals. The logic was old, but sound. If intelligence exists elsewhere, it would likely communicate using universal constants. Mathematics doesn't change across the cosmos. Physics remains physics. Prime numbers are prime on every world where thought exists. In 1974, humanity transmitted the Arecibo message toward the globular cluster M13, a string of binary data encoding fundamental mathematical concepts, atomic structures, and human DNA. It was a message designed to be recognizable to any civilization that understood chemistry and numbers. What if someone else had perfected that same approach but hidden it in the structure of matter itself? The deeper researchers looked, the stranger the data became. The absence of iron wasn't just unusual, it was informative. Iron is element 26, nickel is element 28. Removing iron created a gap in the periodic table structure, a blank space that drew attention like a missing word in a sentence. And that high CO2 ratio, 8:1, could be read as binary if you wanted it to be. 8 and 1, ones and zeros, the fundamental language of digital encoding. It sounds like apophenia, like humans finding faces in clouds, except the patterns held up under rigorous analysis. Machine learning algorithms, trained to detect structured data in noise, consistently flagged the emissions as non-random. The mathematics was too clean, too deliberate. One MIT computer scientist described it as molecular Morse code. The term that began circulating in classified briefings was even more provocative: von Neumann probe, a theoretical concept described by mathematician John von Neumann in the 1940s, a self-replicating machine capable of traveling between stars, gathering resources, building copies of itself, and transmitting information back to its creators. A scout, a messenger, an autonomous agent sent across the void to explore, analyze, and report. 3. I/ATLAS fit the profile. The refined metals could serve as structural materials. The odd chemistry might represent fuel or propellant. The mathematical patterns might be diagnostic signals, a way for the probe to communicate status or findings back across interstellar distances, using nothing but the physics of sublimating gas. But if it was transmitting data, to whom? And more urgently, if it was testing us, analyzing our response, measuring our capabilities, what happens when we respond? What happens when the makers of this thing realize we're here, watching, aware? The questions hung unanswered in secure facilities across the globe, while overhead, the object continued its impossible journey through the inner system, trailing a plume of engineered metal and encrypted chemistry into the solar wind. Space is not empty. Between planets, across the asteroid belt, through the Kuiper Belt's icy expanse, millions of objects trace their endless orbits according to gravitational mathematics that hasn't changed in eons. These trajectories are predictable down to meters. Asteroids don't spontaneously shift course. They can't, until they did. On August 15th, astronomers tracking near-Earth objects noticed something subtle in the orbital data of 3 asteroids in the inner belt. Slight alterations in their trajectories. Nothing dramatic. Shifts of a few dozen meters, acceleration changes measured in millimeters per second. The kind of perturbations that might result from, what? Solar pressure? No, wrong magnitude, gravitational interactions. No nearby massive objects existed to account for the changes. The alterations had begun precisely when 3 I/ATLAS passed within 0.8 astronomical units of the asteroid belt. Dr. Emmanuel Sato, working with the European Space Agency's tracking network, pulled the data for every asteroid within 5 million kilometers of the object's path. 12 showed anomalous motion. All 12 shifted in ways that conventional models couldn't explain. He ran the numbers through every physical framework humanity possessed: radiation pressure, magnetic field interactions, thermal effects, even tidal forces. Nothing fit. The mathematical residuals, the unexplained remainder after accounting for known physics, remained stubbornly present in the data. ESA coined a term for it: gravitational whispering, microscopic distortions in local space-time. Ripples too faint to originate from natural sources but strong enough to nudge multi-ton asteroids off their ancient courses. The effect was subtle, distributed, and, most disturbingly, synchronized with electromagnetic pulses emanating from 3 I/ATLAS. When the object's emissions spiked, asteroids accelerated. When emissions faded, the gravitational perturbations ceased. Correlation doesn't prove causation, scientists cautioned, but correlation this tight demands explanation. 2 hypotheses emerged in the classified briefings that followed. The first, 3 I/ATLAS, was mapping the inner solar system's gravitational landscape, using controlled pulses to probe the structure of spacetime around planets and asteroid fields, like sonar mapping ocean depths, but executed in 4-dimensional spacetime. The second hypothesis was darker. It was probing for weaknesses, searching for orbital resonances, gravitational soft points, vectors where a small force might cascade into larger disruptions, learning not just where things were, but how to move them. Neither explanation offered comfort. At NASA's Jet Propulsion Laboratory, physicists began recalculating trajectories for Earth-crossing asteroids, adding variables for external perturbation. The mathematics grew complex, branching into probability spaces where a sufficiently advanced technology could, theoretically, redirect asteroidal objects with minimal energy expenditure. turned space itself into a weapon simply by whispering at the right frequency. But whispers are subtle, gentle. What concerned researchers more was wondering what the object might do if it decided to shout. The James Webb Space Telescope, still tracking the object, would soon reveal that 3I/ATLAS possessed something far stranger than gravitational manipulation. It had a heartbeat. Thermodynamics is a harsh mistress. Objects in space cool as they move away from the sun. Heat radiates into the void. Temperatures drop. Infrared signatures fade. This is the law. This is physics written in entropy and cosmic truth. So when Webb's MIRI instrument, the mid-infrared instrument, designed to measure thermal emissions with exquisite precision, detected 3I/ATLAS heating up as it moved outward from perihelion, physicists ran the calibrations again, and again, and again. The readings didn't change. At 2.4 astronomical units from the Sun, farther out than Mars, the object's surface temperature measured 340 Kelvin, 67 degrees Celsius, hot enough to boil water, hot enough to suggest an internal heat source completely independent of solar radiation. Dr. Yuki Tanaka, analyzing the thermal data at the Space Telescope Science Institute, noticed something even stranger. The heat wasn't constant. It pulsed, regular emissions cycling on precise intervals, 51.2 minutes initially, then shifting to 17.07 minutes as the object approached Jupiter's orbit. She pulled up the gravitational whispering data from ESA. The timings matched. Every thermal pulse corresponded to a measurable distortion in local spacetime. "It has a reactor," she said aloud, alone in her office at 2 a.m. "A working reactor." The implications crystallized with terrible clarity. This wasn't a dead hulk drifting through space. It was powered, active, consuming some fuel source, perhaps the refined metals themselves, perhaps exotic materials hidden beneath the surface, and converting it to energy according to operational cycles. A heartbeat in metal, a rhythm of technology breathing in the void. When she presented the findings to the International Research Consortium, the room of assembled scientists fell into stunned silence. One astrophysicist, a man who had spent 40 years studying comets, removed his glasses and pressed his palms against his eyes. "It's managing its energy output," someone said, "modulating based on proximity to gravitational sources. Jupiter. The gas giant with gravitational field strength is second only to the Sun in the solar system." As 3I/ATLAS approached that immense well of space-time curvature, its internal processes accelerated. The pulses quickened. The reactor, if that's what it was, ramped up its cycle rate, responding to environmental conditions, adapting. The cinematic nature of it struck everyone simultaneously. They weren't observing a comet or asteroid. They were watching something alive in the way machines are alive. An artificial system with operational states, energy management, environmental awareness. And if it possessed that level of sophisticated engineering, what else might it be capable of? The answer came not from space, but from Earth itself. From the Moon. The Lunar Reconnaissance Orbiter had been circling the Moon since 2009, a silent sentinel mapping humanity's first destination beyond Earth with unprecedented detail. Its instruments measured surface composition, magnetic fields, radiation levels, and electromagnetic emissions from solar-wind interactions. On September 3rd, at 1422 UTC, LRO's magnetometer recorded an anomaly. A low-frequency electromagnetic pulse originating from the lunar far side. The hemisphere eternally turned away from Earth. The shadowed face humanity didn't photograph until 1959. The signal lasted 17 seconds, then repeated, then pulsed again in the same pattern 3I/ATLAS had been broadcasting through its metallic emissions. The same 17.07-minute cycle. The same frequency band, the same mathematical structure. At NASA's Goddard Space Flight Center, engineers initially suspected equipment malfunction. They commanded LRO to recalibrate. The magnetometer complied, reset itself, and immediately detected the signal again. Stronger now, as if whatever was transmitting had increased power after confirming reception. Two signals, millions of kilometers apart, humming in perfect resonance. Dr. Rebecca Torres, LRO's principal investigator, authorized an emergency review of all lunar electromagnetic data from the past decade. Teams worked through the night, analyzing archived readings, searching for precedent. They found it in the Apollo seismic data. Between 1969 and 1977, Apollo astronauts installed seismometers on the lunar surface. The instruments recorded moonquakes, meteor impacts, and strange, low-frequency vibrations that scientists never fully explained, dubbed lunar ringing, because the moon seemed to reverberate like a struck bell for hours after impacts. But buried in that old data, now reanalyzed with modern signal processing, were electromagnetic anomalies that matched the current emissions. Faint, sporadic, easily dismissed as instrumental noise in the 1970s. What if they weren't noisy? Two interpretations emerged, both equally unsettling. Interpretation 1, 3, I/A TLAS had awakened something that had been dormant beneath the lunar crust for millennia, something waiting for the right signal, the right frequency, the right knock on the door. Interpretation 2, the moon already contained a receiver, buried, shielded, silent, awaiting activation. And 3, I/ATLAS provided the activation code. Either way, humanity faced the same terrifying conclusion. They weren't alone in their solar system. They had never been alone. The implications cascaded. If something artificial existed beneath the moon's surface, placed there before humans evolved, before dinosaurs walked Earth, perhaps before Earth formed its oceans, then 3I/ATLAS wasn't a first contact. It was a return. A signal sent home after eons of silence, received by infrastructure older than human civilization, acknowledging, what? A successful survey? A completed mission? Permission to proceed? For 3 days, the lunar signal continued its rhythmic pulse. Scientists monitored it with instruments aimed at the far side's most isolated craters, Tsiolkovsky, Gagarin, the ancient impact basins where shadows lie permanent and deep. Then, exactly 1 hour after Webb detected 3I/ATLAS's internal reactor shift to a new frequency, both signals stopped. Complete silence, simultaneous shutdown. As if the conversation had concluded, the message was delivered, the reply received, and now, whatever came next, humanity would have to wait in the dark to discover. In the control rooms monitoring the moon, engineers stared at flat lines where signals had been. No one spoke. They all understood what deliberate silence meant after days of communication. It had sent a message, received a reply, and then went dark. The question that kept them awake wasn't why it stopped transmitting. It was what it had been transmitting to. Machine learning has become humanity's most powerful tool for finding patterns invisible to human perception. Neural networks trained on terabytes of data can detect correlations, anomalies, and structures that would take human analysts centuries to identify. When astrophysicists fed 6 weeks of 3I/ATLAS emission data into advanced AI models, specifically those designed for signal intelligence and cryptographic analysis, the algorithms found something that should have been impossible to miss. Except it had been missed by every human observer, by every conventional analysis tool. Microbursts of binary modulation hidden in the molecular transitions, not in the gross chemistry, the ratios of nickel and carbon that had initially seemed like patterns. Those were decoys, or more charitably, the carrier signal. The real data existed in the timing between molecular emissions. Nanosecond-scale variations in when atoms released photons as they transitioned between energy states. Ones and zeros written in quantum delays. Dr. Pavel Kuznetsov, a Russian cryptographer working with the International Astronomical Union's SETI committee, described it as the most elegant steganography I've ever encountered. Information hidden not in the content, but in the spaces between content, like Morse code embedded in the pauses between words, invisible unless you knew to listen for silence. The modulations repeated in algorithmically structured intervals, not random quantum fluctuations, no noise, deliberate digital encoding that used chemistry itself as a transmission medium. When the AI models attempted to decode the binary sequences, they encountered encryption that resisted analysis, mathematical structures that suggested either highly advanced algorithms or entirely different logical frameworks. Human cryptography assumes certain computational complexity theories. Whatever design this signal might operate under different axioms entirely. But one pattern broke through the encryption, a repeating signature that appeared every 127 transmissions. Prime number. The same signature appeared in archived data from fast radio burst 20201124A, a mysterious millisecond-long pulse detected in 2020 from a galaxy 400 million light-years distant. The match was exact. Same bit structure, same mathematical fingerprint. Two signals, separated by 400 million light-years and 5 years, carrying the same identifying sequence. It suggested possibilities that shattered comfortable assumptions, either multiple probes from the same civilization spread across vast distances, all broadcasting with identical protocols, or something far more unsettling, a universal protocol. A standard communication framework used by multiple civilizations, or multiple iterations of the same civilization, across cosmic scales that made human empires look like mayfly kingdoms. Governments escalated to defense readiness postures rarely seen outside wartime. Not publicly, the public still believed they were observing an unusual comet. But in classified facilities across 20 nations, military satellites reoriented, cyber defense systems activated, and contingency plans for non-terrestrial contact scenarios moved from theoretical frameworks to active implementation. The mood wasn't panicking, it was something colder. The recognition that humanity had stumbled into a conversation that began long before they existed, and the speakers were now aware they'd been overheard. Then the sky itself seemed to distort. On September 18th, during routine recalibration of the James Webb Space Telescope's guidance system, astronomers noticed something impossible. Background stars were bending, not gravitational lensing. Webb's operators knew that signature well. Einstein's equations predict how massive objects warp spacetime, curving light around them like water flowing around a stone. But 3I/ATLAS, at most a few kilometers across, possessed nowhere near sufficient mass to produce visible lensing effects. Yet the stars behind it were distorting. Dr. Chen, now coordinating the international observation effort, watched the live feed with growing disbelief. The effect looked like heat shimmer above summer asphalt, light refracting through layers of disturbed air, but this was space, vacuum, nothing to disturb. The distortion formed a perfect sphere around the object, approximately 8 kilometers in diameter, and it was growing. When Webb's instruments focused more narrowly on 3I/ATLAS, attempting to pierce the distortion with higher resolution imaging, the field strengthened. Starlight bent more acutely. The sphere expanded to 12 kilometers. "It knows," someone whispered in the control room. "It knows we're watching." An energy field, active refraction, technology that could manipulate light itself, bending electromagnetic radiation around a volume of space to render its contents partially invisible. Not science fiction. Human physicists had theorized metamaterial cloaking devices for decades, but this operated at scales and power levels that suggested engineering centuries beyond Earth's capabilities. The implications froze everyone who understood them. If 3I/ATLAS could cloak itself, what else might be hidden in the solar system? How many times had humanity's telescopes swept past invisible objects, never knowing they were there? And more disturbing, why reveal the capability now? Every observation attempt strengthened the field. Every radar ping, every telescope focus, every sensor lock triggered a measurable response. The object wasn't just defending against detection, it was reacting defensively to attention itself, as if observation constituted a threat. One physicist compared it to quantum mechanics, the observer effect written in military-grade technology. Look at it, and it changes. Focus harder, and it hides deeper. But if looking made it defensive, what would happen if humanity stopped looking? No one wanted to find out. Webb maintained its distant observation using minimal power, like watching a predator through peripheral vision. The distortion stabilized at 15 kilometers, but didn't fade. Then, at 11:47 UTC on September 19th, every telescope and satellite observing 3I/ATLAS experienced the same impossible event. Simultaneous sensor failure lasting exactly 37 seconds. And when the systems came back online, nothing would ever be certain again. 5 continents, 17 observatories, 43 satellites, all monitoring 3I/ATLAS, with instruments spanning the electromagnetic spectrum from radio to gamma rays. All went dark at the same instant. Not equipment failure. Failure implies randomness, variance in timing. This was coordinated, precision, from Hawaii's Keck Observatory to South Africa's SAAO to the European Space Agency's Gaia satellite. Every sensor trained on the object experienced what engineers could only describe as induced blindness. Cameras returned static, spectrometers flatlined. Radio dishes heard only silence. For 37 seconds, every eye humanity had aimed at 3I/ATLAS simply stopped working. In mission control rooms worldwide, coffee cups froze halfway to lips, clocks seemed to hesitate, the quiet stretched thin and terrible. Then, simultaneously, the systems rebooted. Video feeds snapped back, data streams resumed. Instruments recalibrated automatically, finding their targets again, but something had changed in those 37 seconds. 3I/ATLAS's trajectory had shifted 0.008 degrees. A microscopic adjustment, less than 1% of a degree, the kind of course change that would require either a thruster burn or a gravitational assist from a nearby massive body, except no thrusters were detected and no massive bodies existed in proximity. The object had moved while humanity's instruments were blind, deliberately, proving it could. At ESA's operations center in Darmstadt, Germany, a technician leaked a classified observation report to a physicist colleague. The leak spread through academic networks within hours, eventually reaching investigative journalists who published fragments despite official denials. The report described something detected during a momentary recovery between the 37-second blackout and system reboot, a hexagonal thermal bloom on the object's surface, lasting 1.3 seconds, radiating at 5,000 Kelvin, hot enough to vaporize steel. Hexagonal, perfect six-sided symmetry. Nature doesn't do hexagons by accident. Snowflakes form hexagonal crystals because of water molecule bonding angles. Basalt columns crack into hexagons when lava cools under specific stress conditions, but those are micro-scale structures or geological formations. A hexagonal thermal signature on a kilometer-wide object in space implied constructed geometry, panels, hull plating, a reactor port opening and closing with mechanical precision. The symmetry of engineered systems. Governments went silent. Press briefings stopped. When journalists asked about the object, official responses became vague, evasive. Ongoing analysis, preliminary findings, no conclusive evidence. But the scientists knew, the engineers knew. Anyone with access to the raw data understood what those 37 seconds had proved. 3I/ATLAS could control what humanity saw. And if it could control observation, what else could it control? The answer came from Earth itself. On September 24th, magnetometers operated by geological survey networks recorded anomalous fluctuations in Earth's Van Allen radiation belts, the magnetic fields that shield the planet from solar wind and cosmic radiation. The disturbances were subtle, but unmistakable. Ripples propagating through the magnetosphere like pond water disturbed by a falling stone. No solar storm explained them, no coronal mass ejection. The sun remained quiet. The ripples occurred precisely when 3I/ATLAS aligned with Earth's orbital plane. Dr. Sarah Kaufman, a geophysicist at NOAA, overlaid the timing data with the object's position. Perfect correlation. Every time the object crossed specific geometric angles relative to Earth, 30 degrees, 60 degrees, 90 degrees, the magnetosphere flexed. "It's pinging us," she said during an emergency conference call with NASA and the NSA. "Like sonar, measuring our magnetic field structure. Deliberate probing, systematic." Whatever intelligence guided 3I/ATLAS was analyzing Earth's defenses. Not military defenses, but the natural electromagnetic shielding that made life possible. Learning the frequency, strength, and configuration of the fields that protected humanity's cradle. Then came the deep ocean signals. Hydrophones operated by the Comprehensive Nuclear Test Ban Treaty Organization, designed to detect underwater nuclear explosions, picked up low-frequency vibrations from the Indian Ocean floor. Not seismic, not biological. Something that sounded like machinery. Pulses repeating every 12 minutes. Directional rather than radial. Aimed upward, as though something beneath 3 kilometers of seawater was transmitting towards space. Teams reviewed decades of archived acoustic data. The signals had been there for years, dismissed as undersea volcanic activity or whale songs. But reanalyzed with modern signal processing, they revealed structure, mathematical intervals, a rhythm that matched, frequency shifted due to water's acoustic properties, but undeniably matched the pulses from 3I/ATLAS. Something had been waiting on Earth, something was now responding. The discoveries accelerated. An amateur satellite tracker in Argentina noticed unusual behavior from a privately owned CubeSat that normally photographed agricultural land. The satellite's temperature readings had plummeted despite batteries showing full charge. Its reaction wheels, the gyroscopes used for orientation, were spinning in patterns that defied its programming. and it was transmitting. The signal matched 3I/ATLAS's electromagnetic signature. Engineers at the satellite company attempted to regain control. Commands were ignored. The CubeSat had been hijacked, not through hacking, but through direct physical manipulation. Its electronics rewired remotely. Its antenna was repurposed. 3I/ATLAS had seeded a relay. Using human hardware exploiting Earth's own satellites, it had extended its network. The CubeSat now orbited as an alien repeater station, bouncing signals between the approaching object and whatever waited beneath the Indian Ocean. The message wasn't just sent, it was delivered. And humanity stood in the middle of a conversation they didn't understand, conducted in frequencies they barely detected, between entities that predated their civilization. There are moments in history when everything changes, when the comfortable certainties that structured human understanding simply dissolve, leaving nothing but raw truth and terrible wonder. Metallic composition refined through processes nature doesn't possess, chemical ratios encoding mathematical sequences, energy signatures from an internal reactor pulsing with adaptive intelligence, gravitational manipulation, cloaking technology, the ability to disable Earth's observation systems at will. Piece by piece, across 3 months of increasingly frantic investigation, scientists had assembled an impossible conclusion from unimpeachable evidence. 3I/ATLAS was not a comet, it was a machine. A probe sent across interstellar distances, carrying technology centuries or millennia beyond human capability, executing a mission programmed by minds humanity couldn't fathom. It had entered the solar system, surveyed the planets, probed Earth's magnetic defenses, awakened dormant receivers buried in humanity's moon and ocean floor, and established a communication network using Earth's own satellites. And it had done all of this while humanity watched, helpless and amazed, through instruments that could measure but not affect, observe but not intervene. The philosophical implications rippled through academic institutions and military command centers alike. For centuries, humanity had searched for signals from the stars. SETI telescopes had listened for decades, hearing only cosmic noise. The Arecibo message had been sent in 1974, carrying hope that someone, somewhere, might hear and reply. But the contact humanity had imagined, radio transmissions, mathematical greetings, patient exchange of information across light years, wasn't how first contact happened. It came unannounced, silent, already inside the perimeter, not as a greeting, but as a return. Because if ancient receivers already existed on the moon and Earth, placed there before recorded history, before human civilization, perhaps before humanity itself, then 3I/ATLAS wasn't visiting. It was coming home. Above Earth, the hijacked CubeSat continued its orbit, repeating the alien signal every 17.07 minutes. Engineers could see it, track it, but they couldn't shut it down without destroying it. And destroying it might, what? Trigger a response? Escalate the situation? Prove hostile intent to something vastly more advanced? So it orbited. Each pulse rippled through Earth's magnetosphere like a finger tapping against glass, resonating with the deep ocean transmitters, bouncing toward the moon's shadowed face, and outward toward 3I/ATLAS, now approaching the edge of the solar system on its impossible retrograde path. The pulse didn't ask questions, it stated facts. We're here, we remember, we're active, and every broadcast carried an implicit message humanity could finally understand. 3I/ATLAS didn't come to visit. It came because it remembered us. Or rather, it remembered what had been placed here long ago. The infrastructure, the receivers, the seeded technology waiting for a signal. Humanity had lived its entire history under the gaze of something ancient, something patient, something that watched and waited while civilizations rose and fell, while species evolved and went extinct, while continents drifted and oceans filled. And now, finally, that something had decided to check on its investment. In the sterile control rooms and classified briefings, one question dominated all others. A question that echoed in the minds of everyone who knew the truth. A question that kept them staring at the ceiling at night, waiting for dawn, dreading the answer. What happens when the reply arrives? Because 3I/ATLAS was the message, the probe, the knock on the door to say someone remembered Earth existed. And if someone sent a probe to check on ancient installations buried in humanity's solar system, that meant the senders were still out there, still watching, still waiting for the right time to come themselves. The hijacked CubeSat's signal pulses through magnetic field lines, a heartbeat in metal and mathematics, counting down towards something humanity can't yet see. Somewhere beyond the solar system's edge, in the darkness between stars, perhaps something is listening, perhaps something is already on its way.